In this section, we will learn how to include the configuration of the stereocenter in the name of the compound. It is actually quite simple. If there is only one stereocenter, then we place either R or S at the beginning of the name. Consider the following example. Based on everything we learned in the nomenclature section, we can call this molecule butane-2-ol. Here we have the stereocenter as it is connected to 4 different groups. The numbering corresponding to each group is the following. And as you can see, we go from 1 to 3 in a clockwise. So the configuration for this stereocenter is R. And therefore, the name corresponding to this compound is R-butane-2-ol. Here's another example where the configuration for the stereocenter is S, and therefore the name is S-butane-2-ol. If more than one stereocenter is present, then we must also use numbers to identify the location of each stereocenter. Let's consider the following example. Based on everything we learned in the nomenclature section, we can call this molecule 3-bromo-4-chloro-pentane-2-ol. Now we must add the configuration to the name. The stereocenter are here. The first one is S and the second one is R. S is the configuration of the third carbon. R is the configuration of the fourth carbon. So to name this molecule, we will add 3S and 4R at the beginning of the name. And we will call this molecule 3S, 4R, 3-bromo, 4-chloro-pentane-2-ol. Now let's do an exercise. Let's name each of the following compounds, including stereochemistry, in the beginning of the name. For the first example, we begin by applying the rules we saw in the nomenclature section. So first, we determine the functional group, and here it is the alcohol. Next, we need to determine the parent chain. As we can see here, this compound has a double bond. So the parent chain must include this double bond and be as long as possible. And for this reason, in our example here, the parent chain is this one. Now we number it in such a way that the functional group gets the lowest number possible. So in this example, we number it from right to left. Everything else connected to the main chain is considered as substituent. And here we have a bromo substituent. Now we need to locate the stereocenter. And in our example here, the stereocenter is here. It is connected to 4 different groups: the hydroxide group, the methyl group, this group here, and of course the hidden hydrogen. We need now to assign numbers to each of the atoms connected to this stereocenter. Oxygen has the highest atomic number, so it will get the priority number 1. Hydrogen is the smallest atom, so it will get priority number 4. And now we have 2 carbon, and we need to assign priority, so we need to go further and look at the atoms connected to these 2 carbons. For this case here, we have 2 carbon connected to this one because we have a double bond and a hydrogen atom. And in this case here, we have 3 hydrogens connected to this carbon. Carbon beats hydrogen, so this carbon here will get priority number 2, and this one here number 3. And of course hydrogen number 4. And since hydrogen is on a dash, then we can determine the configuration directly. We go from 1 to 3 counterclockwise, so the configuration for the stereocenter is S. Now this compound includes also a double bond, and we need to determine the stereoisomerism of this double bond, whether it is Z or E. So we identify the two groups on each side of the double bond. So we add the hidden H here, and we have bromine and a methyl group from one side, and this group here and the hydrogen from the other side. We need to number bromine and the methyl groups based on their atomic number. As you recall, bromine has a higher atomic number than carbon, so it will get priority number 1, and the methyl group priority number 2. We do the same thing for these groups here. So here we have a carbon, and here we have a hydrogen. Carbon has a higher atomic number than hydrogen, so this group here we get priority number 1, and hydrogen priority number 2. Now we ask ourselves, if the two groups with priority number 1 are on the same side, then the stereoisomerism for this double bond will be Z, and if they are on the opposite sides, then the stereoisomerism will be E. In our case here, we can see that the two groups number 1, bromine, and this group here are on the same side. So the stereoisomerism for this double bond is Z. For this example, we use the same methodology. Now first we determine the functional group. In our case, it is this one here. The parent chain is this one. It is a ring with a double bond. And we have two substituent, two chlorine atoms. Now let's determine the stereocenters and their configuration. In this case here, we have only one stereocenter located here. It is connected to 4 different groups: the hydroxide group, this group here, and this group here, and of course the hidden hydrogen. Now we assign priorities based on atomic number. Oxygen has the highest atomic number, so it will be numbered or given the priority number 1. Hydrogen is the smallest atom, so it will always get priority number 4. And now we need to assign priorities to these two carbons. So we look further to the atom connected to these two carbons. In this case here, we have a chlorine and 2 carbons because there is a double bond. And in this case here, we have 2 hydrogen and 1 carbon. Chlorine has a higher atomic number than carbon, so this one will get priority number 2, this one priority number 3, and the hydrogen priority number 4. So hydrogen is on a dash, then we can determine the configuration directly. We go from 1 to 3 in a clockwise, so the configuration is R. In this example, we also have a double bond, so we need to determine the stereoisomerism corresponding to it. In this case, you can see that we have 2 identical groups connected to this double bond, which are chlorine atoms, and they are both on the same side. So we can call this double bond Z or cis. For the insaturation, we have one double bond located at the second position, so we need to add 2 ene. And for the functional group, we have an alcohol, so we will add ol, and it is situated on the first carbon, so 1 ol. So to sum up, the name corresponding to this molecule is 1R, 2Z, 2,3 dichlorocyclohex, 2-ene, 1-ol. For the last example, we begin by determining the functional group. Here we have an alcohol competing with the carboxylic acid. Carboxylic acids outrank alcohols, so the functional group in our case will be carboxylic acid. We need to determine the parent chain that contains the functional group, and that should be as long as possible, which corresponds to this one. We number it from right to left, so that the carbon involved in the functional group will get the lowest number possible. Oxygen has the highest atomic number. It will get priority number 1. Now we have all the elements to name this compound. And if we start with the first part related to stereoisomerism, we have our stereocenter here located on the third carbon atom configured as R, so it will be 3R, and this one here located on the second carbon atom and configured as S, so it will be 2S. So the first part will be 2S 3R. For the substituents, we have a hydroxide group and fluorine. Fluorine is on the second position, hydroxide on the third, so it will be 2-fluoro 3-hydroxy as substituent. For the parents, we have a chain of 4 carbon atoms, so it will get the bute as parent. In saturation, we don't have in saturation, so we will write AN to highlight that all the bonds are single bonds. And for the functional group, we have a carboxylic acid, so we'll get the suffix oic acid. So to summarize, the complete name for this compound is 2S 3R 2-fluoro 3-hydroxy butanoic acid.